In this short video lecture, I'm going to try to explain the difference between SUM and SUMX function. Before we get into that, I would like to explain why we need so many functions in Power BI. It sounds as if it's very similar to Excel, and yet we have a lot more functions in Power BI. The same table that I have here in Power BI, I have constructed in Excel, and this is the difference. In Excel, of course, in the first column we have product and then price and quantity, and I can go here and highlight and get the auto sum for both the price and quantity. Okay, so here I can say B2 times C2, which gives me the revenue for that particular product. Then, if I want to refer to this cell, 8770, for some reason, I can sit here and say D2 over D2 over, this is in B10, no, I'm sorry, B2 over B10. I can do that, and I am immediately jumping to B10 and including it in my formula. And this jump is not possible in Power BI. If you go to your Power BI screen here, yes, the sum is calculated, but I cannot, there is no way for me to refer to this sum unless I refer it in a formula and understand how this sum is calculated. In Excel, I don't have to do that. I can simply jump to a cell and bring the value. Here, there is no such thing as jumping to a given cell, and that's because in Excel, we have what is known as a cell reference. Any formula that you type in Excel has the context of a cell. Okay, you can go to a cell and include it in your refer to it and include it in your formula. So the context of a formula in Excel is a cell. In contrast, in Power BI, either you have a row context. If you don't say anything, you have a row context, or you may have a filter context. A filter context refers to maybe a table filtered based on a certain condition. Okay, so either you can type in a formula that has a row context or a filter context. Let's see how that works. In the case of SUM, we can calculate the revenue for each product by multiplying price times quantity, and then you have a revenue for each product, and you can sum that revenue, which is what we have done here using the SUMX function. I will show you how this is done in SUMX function shortly. The same thing when you do in a sum function, you say price times quantity, then copy the formula all the way down. Something similar to copying the formula all the way down is including that measure in your visual. So here it is adding all the prices and coming up with a value of 8770, adding all the quantity, coming up with a value of 64, and simply following the procedure we did for establishing this measure price times quantity. It multiplies some price times some quantity and gives you this number, which of course is incorrect. We cannot do that, right? You cannot sum all the prices and sum all the quantity and get the product of the two. In contrast, you have to just go ahead and add the value of all the revenue of individual products to come up with a total value. So that's what I have done here in a card. Here you have a sum measure. So if you go to sum measure, I say sum furniture quantity, which refers to a column, times furniture price, which refers to another column. That gives you an incorrect number using the sum function. Whereas in the SUMX function, although there is a difference, that's simply because we are rounding it to the nearest thousand. So if you go and look at the SUMX here, we are saying SUMX furniture, which is the name of the table, and we supply an expression. That's the syntax of the SUMX function. In this table, compute this expression. Okay, furniture price times furniture quantity. So when it gets to the sum, it doesn't multiply these two, it just sums all this, which is the correct computation. So the difference between SUM and SUMX, to think of it another way, SUM works vertically downwards. Okay, then when it computes the sum, it just multiplies each row. Whereas SUMX works horizontally for each row. Okay, it's an iterative function. It calculates the price times quantity for each row and then does the sum. So that is the difference. Okay, so without the total row, the numbers appear to be the same, but there is a difference in the way that these two works. And in order to understand this, and from your perspective, you have to understand when to use what. Okay, sum, if you look at the syntax of the sum, it is a simple column. Of course, you can compute an expression. It's a simple column that is applied as an argument for sum. Whereas SUMX, if you want to do a lot more, you can do a lot more things with SUMX while you aggregate a certain value. For example, you can apply some filters, you can do the sum based on a certain condition and so forth. I will illustrate this shortly. So the SUMX is plain sum of a column or a computation of two columns, as we have shown here. Whereas SUMX is a lot more extensible, in the sense you have a lot more flexibility on how you calculate SUMX. So in order to illustrate the kinds of things that you can do with SUMX and you cannot do with sum, I'm going to try to calculate the discount here. Okay, I'm going to say the discount is 5%. Okay, so I can calculate another measure, new measure, and I'm going to call the disc measure to indicate that it is a discount measure. And that would be SUMX measure times 0.05. Okay, 0.05. So I highlight the visual and include the discount measure. Okay, and you make it visible. I have calculated the discount for each one of the products. So that's something you can also probably do with sum. And I'm going to erase that for the time being. Now I want to apply some condition. Okay, I'm going to give the discount only for those products for which the total revenue exceeds $10,000. So I will say this once more. I don't want to give a 5% flat discount for every product here. Only when the sum revenue exceeds $10,000. In this case, the revenue exceeds $10,000 for bookcases and tables. So for only those products, when the total revenue exceeds $10,000, I'm going to give a 5% discount. In order to do that, I'm calculating another measure, and I'm going to call this R discount measure, which is the restricted discount measure. Okay, and now I'm going to use SUMX because it's a lot more flexible. I'm going to use a table and then an expression. Instead of a table, I can supply a filtered table. Okay, so I can say filter the table name is furniture, and the filter expression is SUMX measure, which is the revenue exceeds $10,000. So do you get the first part of the filter here, SUMX function? Instead of supplying a plain table, I am supplying a filter. Okay, so SUMX filter, and this is the filter for the table only when the revenue exceeds 10,000. Then I am going to calculate the discount. Okay, so in this case, instead of calculating the discount, I am going to calculate the revenue after discount. So I can say 0.95. If I am giving a 5% discount, my value is SUMX measure, my revenue is this, right? I'm giving a 5% discount, which is my revenue, which is in this column SUMX measure, which is price times quantity, and I realize after discount 95% of the value, and I close it, and you can see the parenthesis closes the first parenthesis, and I hit enter. So that's my restricted discount. Now I am going to give the restricted discount. Okay, and you can see the discount is given not for every product, but a filtered value of the product, filtered table based on SUMX measure is greater than 10,000, and it gives you the revenue which is not SUMX measure but somewhat less than SUMX measure, 5% less than SUMX measure. Okay, so that is one thing that you can do, and these kinds of things are not possible with SUM function. And the same thing I'm going to do now. These are all blank, right? I don't want to leave this as a blank, so what I am going to do here is do exactly the not exactly the same thing, somewhat similar, but now you will see what this does. The table is furniture, SUMX furniture. Now my expression is going to be an if statement. If logical test is SUMX measure exceeds 10,000, it's just like an Excel function, 10,000, then the value if true is SUMX measure times 0.95. If it is false, meaning if the SUMX measure, the revenue does not exceed 10,000, then my value is going to be simply SUMX measure. Okay, I'm sure you understand the Excel if function. That's exactly what I have. This is my table, and this is my if statement. If SUMX measure, which is the revenue, and now we calculated it by simply price times quantity. Okay, now if it's greater than 10,000, then I am giving a 5% discount and realizing a value of 0.95 times 0.95 of the revenue. And then if it is not greater than 10,000, I realize the full revenue. So that's my thing here. So here, if you look at it, that's already included in the table. For those products where the revenue exceeds 10,000, my value realized is simply 95%. For other products, it is simply the actual revenue because I'm not giving any discount. And it sums correctly this. Without discount, I would have realized 53,500. With discount, I realized 52,250. So that's the difference between SUM and SUMX. In summary, there are two things that we talked about. First, SUM, the plain sum function, works vertically downwards and calculates the sum for each column, and whatever computation is needed, it does it for the total column, which is incorrect. For the total column, it's incorrect. Whereas the SUMX function, the difference is it works iteratively, row by row, horizontally, iteratively, row by row, and computes. And it is a lot more flexible in that you can apply a filter, if condition, and so forth in the SUMX function.